Hi, my name is Adem, and I'm an aspiring architect of fabric structures. This presentation is intended to inform the audience about the nature and application of these structures, and to introduce to you Tripar, a brand new stage cover. Against a boxy urban environment, fabric structures stand out in style, with a curvilinear dynamic, visual lightness, translucency, and clear open spans. They can possess a fleeting character, as opposed to the permanence and monumentality of heavy traditional construction. Tensile structures are an assembly of elements intended to carry only tension and no compression or bending. Fabric structures are tensile forms comprised of oftentimes lightweight frames, cables, and constructed fibers. These fibers are generally woven fabrics rather than meshes or films. They can be engineered to meet international requirements such as flame retardancy, weather resistance, structural, and natural forces. The most common materials are polyesters laminated or coated with polyvinyl chloride, woven fiberglass strands coated with polytetrafluoroethylene or silicone, thermoplastic foils such as ETFE, THV, or PVC, or even coated steel cord textiles. Recent developments have opened possibilities for new material combinations to enhance and further customize fabric properties. This includes a woven PTFE scrim doubly coated with PTFE to withstand repeated flexing and folding, as opposed to brittle glass fibers. Membrane structures can be designed for a wide variety of purposes, both temporary and portable, as well as permanent. To name a few programmatic opportunities, there are applications for special events, outdoor performances and ceremonies, catering, warehousing, storage, and disaster relief. Next, I will provide a brief overview of the relevant history and science of fabric structures that will lead into my stage cover design. Architecture based on tension has a history that stretches back over 44,000 years from the Ice Age and the Siberian steppe, at a time when our ancestors draped animal skins over sticks to separate themselves from an unforgiving nature. Rome's first amphitheater, the Amphitheatrum Caesareum, known today as the Colosseum, once accommodated 50,000 people seated around a central area. Recent research identifies that velarium was used, which is essentially a fabric cover that protected the audience from sunstroke. The diurn tent was an individualized ridge tent without doors, comprised of panels and used in the Roman military. Royal tents became fashionable in Western Europe, growing larger and ever more ornate. These tents, due to their material ephemerality, developed a much more architectural quality than their predecessors, as a symbol of luxury and frivolity. Walter Bird established Bird Air for the sale of the radome, an inflated spherical device for climate protection of radar dishes. Architect Bertel Olaf Zenitz created a triple arc cable net structure with arc tangencies at endpoints forming 90 degrees. From the roof, the plan forms a circular profile and fabric spans the edge condition of rigid arcs. The original hyperbolic paraboloid-shaped stage cover was by pioneer engineer Frei Otto, who developed the canopy for the Music Pavilion in Kassel, Germany. Fabric structure industries came to develop more reliable fabrics and employ advanced structural design techniques. In this example, Kurt Warner at WSSL designed and developed the arabesque stage cover, with brothers Gary and Rolf Warner before establishing separate companies. Today, advanced computational techniques have supplanted the former manual process of fabric structure design and have aided in the service and delivery of membrane architecture. Pre-stress is the introduction of internal stresses into a structural member to counteract the stresses resulting from the applied load. To demonstrate, pre-stress cross cables both act in tension during the application of shear stress, as opposed to tension and compression when loose. Arches and domes are the forms most capable of spanning larger distances more efficiently, as their funicular form most evenly distributes the load towards the ground. Membrane structures are activated in tension either pneumatically by inflating fabric and creating a synclastic form, or by creating an anticlastic form, with opposite Gaussian curvatures acting in perpendicular directions, known as hog and sag. What is created is a minimal surface which most efficiently transfers load while minimizing material use. The dominant algorithm for determining minimal surface is the force density form finding method. When employed, it can quickly generate replicable results and structures of high quality and flexible adaptation. External forces balance with internal forces at an equilibrium state around a pin-jointed network. In order to turn a non-linear set of equations into a linear one, the force density ratio is fixed. This creates the opportunity to perform the static analysis of geometrically non-linear structures by using Hooke's law. Double curvature in fabric can only be approximated by joining two-dimensional cutout equivalents of their 3D counterparts, known as patterns, by being careful of the width of a given roll of fabric. Other edges can be extended and chamfered to create overlapping seams, and fit cables or ropes in order to form caters. Caters and cable edges can be used to connect to structural members by extruded luff traps or rope clamps. Most fabric, with the exception of foils, have different material properties when measured on separate axes, known as anisotropy. The direction dependence of fabric orientation is based on both the weaving and coating process. The strong lengthwise direction within a weave is referred to as the warp, and the secondary direction is known as the weft, or fill fiber. Warp threads differ as they are subject to higher tension on a frame or loom. Weft jump occurs during the heating process, as warp threads are kept under tension while weft threads contract and are thus softer with lower moduli. PTFE exhibits a strong resistance to common industrial and traffic pollutants. The carbon-fluorine bond is one of the strongest in organic chemistry. The low polarity of the fluorine envelope in PTFE chains leads to an anti-adhesive behavior with a very low surface energy. Central staging, or concert in the round, is any space whereby the stage area is surrounded by the audience. Standard staging is a typical format with a limited angle for audience viewing. After applying the Jacobs method, a calculation used to determine rough estimate of crowd population in a given area, it was determined that central staging can accommodate up to 3 times more people with improved viewing conditions of the stage. This is due to a tendency for the densest crowding closest to the center of attention. In other words, central staging means that more people can be at the front of the action. From the 2 hinged arches of the aforementioned arabesque stage cover comes a possibility to split and rotate the arches to add a third, modifying details accordingly. Due to a greater risk of ponding from the minimal surface created by the triplicated arch edge condition, 3 ridge cables must connect from the kink in the arch to a central ring to be protected by pockets. To enhance sight lines and usable space beyond the cover, canted masts transfer cable loads to triangulated cable tiebacks. Installation is a crucial part in the consideration of membrane structure design. Here, we will illustrate the installation for the Tripar 25. Fabric, base space for cables and masts, are first laid out in their respective locations. Arches are bolted together on the ground, with one having the apex crossing the center. Fabric is then unfolded and attached to the outermost edges of the arches by an adjustable carabiner clip system. Next, 4 cables are attached to each arch, and 2 of the arches are lifted with a mechanical boom until both arches reach roughly 90 degrees to allow for the attachment of the fabric of the last arch. Masts are then lifted and connected with the cables along the arch perimeter. Finally, the canopy is leveled on all 3 sides to create a 45-degree cant. Wind and snow load are calculated separately using ASCE design codes and NBC requirements. The final values enter the finite element analysis software, whereby warp and weft stress plots help to determine whether the fabric can handle the loading under various wind conditions. These include maximum uplift or downforce at both 0 and 60 degrees to the canopy. An HSS framed baseplate supports hinge axes, horizontally oriented at 60 degrees to one another, about which triangular trusses may connect and pivot from the top edge of the hinge plate. Circular section pipe is curved before identical struts, pressed at both ends, are welded in a Warren fashion, connecting 3 identical arcs which comprise the chords of the triangular truss. Conical adapters with R-clips fasten at male-female joints to connect each modular part. A mast hinges on a ball and socket joint connected to an anchored baseplate, transferring loads from the arch trusses to the cabled baseplates on the ground. Since tangential forces are complex and unpredictable, fabrication would have to meet high tolerances in order to switch this detail to a moment connection. A hinge toggle cable baseplate is anchored by stakes. Cables can be adjusted by using turnbuckles to increase pretension. In order to economize the use of the fabric, patterns are to be based on a repeatable module, a sextant of the overall top. Radial and linear symmetry enable a single pattern sheet to be duplicated 6 times. Pattern offsets for welding and pockets are added to account for the ridge cables which span from the apex to a central ring. The fabric is scaled by 0.025% as compensation for pre-stress. By this measure, the top arrives on site slightly smaller and is then stretched into its actual size. Tripar, with its unique and dynamic form, has a multitude of programmatic uses, including concerts, theater performances, weddings, ceremonies, and special events. Its portability and adaptability make it possible to set up almost anywhere and allow for a wide variety of arrayed configurations to expand the covered area. Again, I'm Adem, and thank you for watching.